Welcome to 3Mac. Do you want to learn about computational design, advanced manufacturing, materials modeling, or integrity assessment? Then this is the channel for you. I regularly upload new content, so please hit the subscribe button below for regular updates. Hello everyone, apologies for the delays and being absent for a few weeks now because of I was busy in teaching and other stuff. So in this small video I have been asked by a subscriber to how to simulate repetitive impact of a steel hammer with the concrete slab, as you see in the picture. So you have a steel hammer. I have simplified the geometry because the geometry was slightly different, which was provided by the subscriber, and this is the slab which is simply supported in a way, or supported like this in the real case. So, and it has to impact repeatedly. Again, the data is not given fully. It was just stated that this should impact this slab repetitively with a velocity of 2.8 meters per second. So, and also it should be hit 4 or 5 times. And if I can show what sort of how to model the damage, so I'm going to show you that in today's video. Okay, as the first part of this thing, I will show you how to get the velocity profile, and then we can apply the velocity in a cyclic way. And this is one of the approaches when your damage is not really affecting the overall profile of the structure, but if it's affecting everything, then you might have to come up with some other approach, and I will discuss some of those approaches rather than just showing those. So first thing is to get the velocity profile. Since it's a kind of a free fall motion, so you can have two options. As you can see, I have two models here. One is based on the gravity, the other one is based on the velocity profile, where we basically initialize a velocity as an initial condition, and then we let it move in that direction, and then it automatically comes in contact or impacts the other object, and then the velocity and everything is solved by the solver itself. So this is the first approach we're going to do. Again, you can see I have two parts. I have simplified the hammer as a cylindrical part rather than modeling as the actual hammer. I have a beam which is a kind of a simply supported beam from the bottom. I have distributed or divided this geometry into these sections here so that I can have a finer mesh at the supports. Again, meshing is not a point of discussion here, so again we have discussed that a lot of time in my other videos, so you can look at those. Here I'm just going to show you the methodology of doing the simulation of a free falling hammer impact on a concrete slab. Okay, so these are the parts. If you go to the properties, I have to define the properties for the slab and also for the fiber. So I have defined the properties for both with failure and without failure. And if you look at without failure, then this is just the density and the elastic properties I'm using, which are given here, which I have again discussed in my other videos on the concrete. If I want to define the failure, then I have used a brittle cracking. You can again define plasticity in concretes as well. There are different models in ABAQUS, but I've gone with the brittle cracking, and I have to define the brittle shear and failure. If you want to learn about these things, then look at the video shown on the top, and that in there I have discussed all these parameters in more detail than here. So these are the parameters I have used for concrete with failure. Again, these parameters are the same. And then also for the steel, which is for the case of hammer, and I have defined the density of the steel and also the Young's modulus and Poisson's ratio. Once I have done that, I go to the assembly. I create a solid section. As you don't know, you have to do that, and you basically then assign it to individual components. Again, you can look at my other video how to assign solid section, but what you have to do is create a solid section, select whatever homogeneous solid, and then you can select a material and it will create a section for you, and then you can assign that section by using this button here. So assign section, it will ask you to select the component. You press done, and then it will give you option which section you want to assign to. I already have assigned it, so I'm not going to do it again, but if you're confused, just look at the other videos where I have discussed this in detail. Then I go to the assembly module, and what I have done is you can instance the parts. So I have instanced both the parts, and I kept them offset as you see here. And then I have, so you see the hammer is somewhere there, slab is somewhere here, so I had to move this and bring it here. So what I have done is I've used this translate option. You can select any object, and then it asks you to initial point, and then ask for the other point, and you can move it to anywhere. So what I have done is I have brought it down to a kind of a center position, middle position of the slab itself. Okay, so this is how it looks like from the assembly perspective. From the step, again, I'm doing a dynamic step because it's a dynamic problem. So I'm going to run it for 0.03 seconds because I have kept a distance, and then based on the velocity, I found out how much time it's going to take to impact. And that's what I have done here to define the time. For when you create the step, you have to define the time period. Rest of the step I have left it as default, so I haven't changed anything at all. Okay, that's for the step definition. Interactions, I have defined the general contact here with the interaction properties of one, and I'm going to show you what these properties are. So I'm just using a general contact, so I let ABAQUS to find out when any of the objects come in contact with the other. For the interaction properties, as I showed you there, which was interaction property 1, I have used frictionless contact. Again, if you know the frictional coefficient between the two, you can specify that. And for the normal contact, I have used a hard contact. This means based on the stiffnesses, it will identify the stiffnesses or contact pressures between the two contacting surfaces. I have a rigid body constraint. What I have done is, you can make this thing elastic as well, as I have done that, but what I have done is I have created a rigid body constraint and make this thing as rigid, because we are not interested in any deformation of this, rather we are interested in the failure of this, and this is much stiffer than this. So I have defined this as a rigid body here by using, so you need to select a body, which is this one, and then you have to select a reference point. So you see I have created a reference point which is there, and if you look at closely, then this is the reference point at the center here. Again, if you're not familiar with the reference point, then you can create a reference point by going to the reference point here, and then you can select anywhere and you can create a reference point there. So once you have created that, so now I have a rigid body constraint here. And if you are really new to ABAQUS and you're finding it hard to follow what I'm saying, I have a course on ABAQUS with explicit, standard, and CAE, so please go through that, and it will definitely make you learn this tutorial or understand this tutorial better. Okay, then we go to the loading. In this case, the tricky part is I have no forces. I have fixed the bottom parts in all the direction. In this case, what I'm assuming, I was not provided any more conditions, so I just fixed everything at the bottom. For the top, I can see I have fixed this reference point because now it's a rigid body, so I have to apply the boundary condition on the reference point. If it's an elastic body, then you can define any of the surfaces. So I fix all the degrees of freedom except for the vertical one, which is the U2, and you see I haven't selected the U2 here. So it's fixed in all the direction along with the rotation, but it can move freely in the U2 direction. Now, since I don't apply any velocity boundary condition, what I do, I want to define the initial velocity condition as a velocity. So what I do is I go to the predefined field manager, and then I create a predefined field, and I can specify a mechanical velocity. Once you click on this, then you will get this kind of window. So here you can define the velocity, and I'm defining a velocity of this in the vertical direction, and since it's going in a negative direction, so I have put it a negative value here. Again, this value is coming from the subscriber. So then I go to the meshing. I do the meshing again individually. I have done a hex mesh for this, some refined mesh here to avoid any issues related to boundary conditions, and then I'm using also hex side type mesh for the hammer as well. And this is how it looks like. Again, I'm not discussing about the mesh optimization, we have covered it in other videos, so please go and have a look at that. Then I go to the job, I press create, I select this, and then I create a job. So what I have done here is, if I can find, so I don't have it here, so let's run it. So I will just create this job, and I will call it to get velocity profile. So that's what I'm going to do now. I will just select double precision, because if the number of increments are very high and the size of the increment is very small, and it goes with a full precision, and then I submit. Once I submit, I can monitor this stuff, and now we have to wait patiently to see if it runs. Okay, so it is running now. and it should be quick because it has to finish in 0.03 seconds. So you see it's going pretty smoothly by now. You can check the output. It has already written the output for first frame, so and now the second one as well. So we can go and we can look at the frames if you want to. So what I can do, I can go here and I can, it says running, so I just press results, and you see here this is how it looks like, and you see it's moving down currently. So it started to move down because of the initial velocity condition, and once it strikes, it will automatically solve based on the contact pressures and stiffnesses how the velocity decreases and what sort of stresses are induced in both the components. Well, in this case it will be mainly slab, because slab is elastic material while the hammer is a rigid body. So again, go back to the monitoring to see where we are. So we are almost 1/3 of the simulation now, you see. So I will speed it up now and I will show you the result as soon as they finish. So you see now it's already finished. So I'm gonna go now and see if how it looks like. So you see it keeps on going, then it comes in contact, induces the stresses, then it reflects back as a kind of a free fall motion. And what you can do from this point onwards is you can take the deformed stress component to a new simulation by importing from here. You can import an ODB file or model from here or a part from here, and then you can do the same analysis again, and you can have as many impacts as possible by doing this. Or what you can do is you can capture the velocity profile from this, and you can basically get the velocity of this thing, how it varies with time when it impacts, and you basically can then plot that. So let's try that first. Create field output unique nodal reaction forces, and then here if I go to the internal sets maybe, or node sets, I should see a reference point here, and if I say highlight, so you see this selecting this reference point. So I will go there, and instead of reaction I need a velocity, so I'm gonna select a v2 as a velocity here, and then I will save it. So now if I go to my XY data manager and if I plot the velocity here, then you see this is how the velocity varies. It was the same throughout because it was 2800 something. Again, this is just because I'm on the remote desktop, so these fonts are based on the resolutions. So again, so you see this is pretty much 2800 until it impacts, and then it starts to slow down and then it goes up. So we have got a kind of a profile, so that can give us kind of an indication, okay, how the velocity varies. So what we can do, we can take this profile back and out as an output. So what I can do, I can report this as an XY data, select this, and then I can say, let's say velocity profile or something like this. Let's call it ABAQUS something, and then I will just say okay. So now I have the data here. Oops. So now I should have a data file here. If I have been in the right folder here. If I open this, then I can basically take this data which I have here, which is here as a function of time, to Excel, and then I can create kind of a cyclic loading. So that's what I'm going to do now. Other way or easier way is, if you are not really familiar with the text editors, you can just go here, you can go to XY data manager, you double click on this right here, you select all of this data, you copy, you basically can select, so you can select all this data, and then you can copy it, and then you can go to Excel and you can plot it. So that's what I have done here. You see I have taken it to that point, and then what I do is I just take it up to whatever value I want. So what I'm going to do, I'm going to repeat the whole cycle I have, so until 0.03. so I just repeat this cycle. So this was the first cycle which I did, and now I have the second cycle. I keep on adding the time based on those intervals, and I keep repeating this cycle until 4 impacts. So now I have like developed until 0.12 seconds the data for velocities for 4 different cycles. So this from this point until 0.3 is the first cycle when first impact, and then it goes up. Then from here until 0.6 is the second impact. Then from this point to 0.9 is the third impact, and then until 0.8 is the fourth impact. So you can get the velocity profile like this, and then you can go back in your ABAQUS. So, and then you basically can create a new model. For example, I go to the part again to make my life simple. I can just copy a model and I can create a new model, and let's say this is the equivalent boundary condition. In this case, what I do now is I just this one, and what I do now is I just go to the loading and boundary condition, and now instead of specifying the predefined boundary condition which I have deactivated, now I apply a cyclic velocity boundary condition. And so for example this one is deactivated, so you can ignore that, and you can see this is 1, and I'm using a displacement or velocity whatever as a boundary condition as an amplitude. So if you look at the amplitude function now, which you can create from here, then you can see my displacement amplitude is the same as what I have copied from the Excel file. So this is from the same as from the Excel file. If I just showed you, it goes up to 0.03 as one cycle, then it goes to 0.06 for the second one, then until 0.12 it will go up to the fourth or fifth cycle. So I have copy pasted that Excel file columns here directly. So I have done here. So this is the only thing which I have changed. So instead of using initial boundary condition, now I'm using the repeated velocity boundary condition coming from the previous analysis, and I'm just using 4 or 5 impacts. Rest of the stuff remains the same. I again have no failure here, and if I can see if I can find the equivalent boundary condition, so I think I have, and you can do the same for the other one as well. So this one is I think from the previous one, but let's check that first. So this one was, yeah, this one is the one which is there. So you see it goes down, then it goes, it hits, and then it comes back up. It comes back up, your structure starts to relax. It goes to the second impact, then it comes back, third impact, fourth impact, and then you reach to the end. And you can see there are waves in your structure. So again, depending on how much time interval is between the impact, these waves which are going through, stress waves which are going through your structure may change as well. So again, you have to decide about those time based on your amplitude function. So this is one way of doing it. However, if you do the same with the damage properties, so for example, this, if you look at this one is the same as the previous one with impact, but now what I have done is basically I have used in the solid section here for concrete with no fail, sorry, for the concrete, I will be using the failure one with the failure. Okay, so here you see the properties are for with failure. And now if I go back to the job, so load again, if I show you the loads, you see this is deactivated as previous, and here I have used the same amplitude and same values there. So this is the same analysis just with the damage parameters for concrete. And now this one is from there. I go there and you see how it looks like now. So you see it, if it works. Yeah, so what you see here is you see it hits and it damages everything again, and based on the damage criteria. Again, I'm not using a realistic values, so that's why the damage is pretty unrealistic, but your damage should be something like this and your cracks should be going in this direction if you use a right mesh and if you use the right set of parameters. So again, as I told you, I'm not really concentrating on the material parameters and the meshing, but that as a user you have to decide how to do it after many number of iterations. This was one way of doing it. The other way around would be, as I told you before, you can go with the gravity effect because it's a free fall motion, and you can use a gravity loading. Here I'm not going to show you the results for this, but I will show you what I have done here. So for this case, everything remains the same. The only thing is the loading which changes. Instead of using the boundary condition, what I have done now is I have created a distance between these two depending on the actual height of the hammer, which was around 0.4 meters or something mentioned by the subscriber. And here I apply a gravity load, which is 9810 in the vertical direction. So everything falls like a free fall. It will take more time to solve, obviously, but it will also give you a realistic picture of damage, because here you are not constraining the motion of this thing with the velocity as a function of time. It's a free fall motion, and every time it comes, it will always hit with a full impact with the slab, even if it's damaged or not. So this is more realistic, but then it will require some more effort. So yeah, so this is another way of doing it. Other than that, if you have an experimental data for displacements or velocities you have measured, or force, for example, if you have load cells on your hammer, then you can apply with that as a function of time. As I showed you, we did it for the velocity, and you can try with that as well. So I hope this makes sense and you are able to do simulation, and the subscriber is also able to get something out of this thing. So you see that how the damage really occurs. I have only output for the limited data, so you only see one impact, but there are 3 or 4 impacts here going on. Again, if you have ductility or plasticity in your concrete, you can use a different model, but again, I'm not a concrete guy, so maybe you have to look into ABAQUS documentation for that. So thank you very much, and I hope to see you in the next video. Bye for now.